Hello, viewers. In today's class, we are going to discuss one important problem from logarithmic differentiation, right? So, in this class, we'll find out the derivative of this function, that is y is equal to x raised to log of x to the base 2 at x is equal to 2, right? So, in this problem, we'll make use of the concept of logarithmic differentiation to get the derivative of y with respect to x. So let us start. Now see, here we are given the function y in the form of x raised to some power, right? So we have x raised to a log of x to the base 2, right? So whenever we have functions like this in which the powers are involved, we make use of the technique of logarithms, right? So we'll first simplify this function with the help of a log, right? So taking logarithm of both sides, we'll get a log of y, and here we have a log of x raised to log of x to the base 2, right? Now see, here we are taking the logarithm of both sides. So here we'll take the logarithm with respect to the base e, right? So here we have the base as exponential number e. So when we have taken the natural log of both sides, we can also use this notation, that is ln y is equal to ln x raised to a log of x to the base 2, right? So either we can use this notation, that is log, and base is e, or we can simply write ln. So here in this problem, I will prefer this notation, right? So now we have a log of y to the base e, and here we have x raised to log of x to the base 2. So we'll make use of the power rule for log, that is log m raised to n is n log m, right? So we can take log of x to the base 2 in front of log to the base e. So we have here log of x to the base e, and here we have log of x to the base e. So now let us differentiate both sides with respect to x, right? So the notation goes like this, that is d by dx of log of y to the base e, d by dx of log of x to the base 2, and here we have a log of x to the base e, right? Now see here, the derivative of log y with respect to x is 1 over y, and by chain rule we'll write dy over dx, right? Okay, now here we have the product of two functions, so we'll make use of this rule, that is product rule for differentiation. So we have first function derivative of second, then second function derivative of first function, right? So we can write log x to the base 2 derivative of log x to the base e, then we can write log x to the base e, and the derivative of log x to the base 2. So now we have log x to the base 2, and here the derivative of log x is 1 over x, right? Because we know that the derivative of natural log is equal to 1 over x provided the base is e. So log x to the base e is same as ln x, right? So we have 1 over x, and here we have log x to the base e, and here see, we have to differentiate log of x to the base 2, right? So here we make use of the base changing formula. So now the base changing formula goes like this, that is log of b to the base a is equal to log of b to the base e divided by log of a to the base e, right? So when we have a log of b to the base a, then we can change the base to the exponential number e by writing log of b to the base e, log of a to the base e, right? So here we have log of x to the base 2. So b is x, b is x, and a is equal to 2, right? So here we have d by dx, and we can write log x to the base 2 as log x to the base e divided by log of 2 to the base e, right? By virtue of this result. So now we have here 1 over x. We can take 1 over x in front of log x to the base 2, and then we have log of x to the base e divided by, now see here we have log x to the base e, log 2 to the base e, and this log 2 to the base e is a constant. So we can take it outside the this derivative operator. So we have log 2 to the base e, and we are left with d by dx of log x to the base e, right? So this is now 1 over x log x to the base 2, and here we have log x to the base e divided by log of 2 to the base e, and the derivative of log x to the base e is simply 1 over x. So now we have 1 over y dy over dx equal to this expression, right? So now dy over dx can be written as, taking this y to this side, we have y times 1 over x log of x to the base 2, and then we have 1 over x log of x to the base e divided by log of 2 to the base e, right? So now we can replace this y by x raised to log x to the base 2. So the final derivative, that is dy over dx, is x raised to log of x to the base 2. And we have 1 over x log x to the base 2 plus 1 over x log x to the base e divided by log 2 to the base e, right? Now we have to find the derivative at x is equal to 2. So now substituting x is equal to 2 in this expression, we have 2 raised to log of x, that is the log of 2 to the base 2, and then we have 1 over 2 log of 2 to the base 2. Here we have 1 over 2 log of 2 to the base e, and here we have log 2 to the base e, right? And see this quantity, that is log 2 to the base 2 is 1, because we know that log of a to the base a is always equal to 1, right? So here we have 2 raised to 1, this quantity is 1, and we have half, again this quantity is 1, so we have 1, then we have half times see log 2 to the base e, log 2 to the base e get cancelled, so we have here only half times 1, right? So this is 2, and we have half plus half, and half plus half is 1, so this is 2 times 1 is equal to 2, right? So the derivative of this function when x is equal to 2 is equal to dy over dx is equal to 2 at x is equal to 2. right? So this is how, by making use of the concept of logarithms, we can find out the value of the derivative at the desired point. Hello viewers, in today's class we are going to discuss another problem from logarithmic differentiation. And in this problem we have to find the derivative of y with respect to x at x is equal to 1, right? So we have to differentiate this function y, which is equal to x cube times the square root of x plus 4 divided by x cube plus 1, right? So here, to find out the derivative of y with respect to x, we can make use of the quotient rule and then the product rule, right? But here we'll prefer the method of logarithmic differentiation by making use of the properties of logarithms. So let us see how we can find out the derivative of y with respect to x at x is equal to 1 using the concept of logarithms. So first we'll simplify this function with the help of logarithms. So let us take the natural log of both sides. So we'll get a log of, that is ln y is equal to log of x cube times square root of x plus 4 divided by x cube plus 1, right? So what we have done here, we have taken the natural log of both sides. Now see, here we have x cube times the square root of x plus 4. So here we have the product of two functions. So what we will do, we'll make use of this property of log, that is log a over b is equal to a log of a minus log of b. So we can now write log of y is equal to log of x cube times square root of x plus 4 minus a log of x cube plus 1, right? So this numerator can be treated as a, and the denominator x cube plus 1 may be treated as b. So now here we have x cube times square root of x plus 4, right? So here again we'll make use of one property of log, that is log a times b is equal to a log of a plus log of b. So now we can write log of y is equal to log of x cube. A can be treated as x cube and b can be treated as square root of x plus 4. So we have log of square root of x plus 4 minus, and we have log of x cube plus 1, right? Okay, now see, we can write these terms as log of x cube, and here we have log of x plus 4 raised to half, and here we have log of x cube plus 1, right? So let us make another important property of log, that is the power rule, that is log a raised to b is given by b times log of a. So in the first term, a is x and b is 3. So we have 3 times log of x, right? And here in the second term, a is x plus 4, b is 1 over 2. So we have half log of x plus 4 minus log of x cube plus 1, right? So viewers, with the help of logarithms, we have redefined this function like this. So now let us differentiate both sides with respect to x. So we have d by dx of log y, then we have d by dx of 3 times log of x, then d by dx of half log of x plus 4, then we have d by dx of log of x cube plus 1, right? Now 3 is a constant, we can take it outside, and the derivative of log x is 1 over x, and here again we have half constant, taking it outside the derivative, that is the operator d by dx, we have half. The derivative of log x plus 4 is simply 1 over x plus 4, right? So here we are using the derivative rule for log x, that is derivative of log x is 1 over x, right? And similarly the derivative of log x plus a is simply 1 over x plus a. And in this term, we have the derivative of log x cube plus 1 as 1 over x cube plus 1. And then by chain rule, the derivative of x cube plus 1 is equal to 3x square, right? The derivative of x cube is 3x square, and 1 being a constant, the derivative is 0. So here we have 3x square. And in the left hand side, we have the derivative of log y with respect to x. So the derivative of log y with respect to x is 1 over y, and then we have dy over dx by chain rule, right? So now taking this y to this side, we have dy over dx is equal to this term is now multiplied with this y here, and we have dy over dx is equal to y times 3 over x plus 1 over 2 times x plus 4 minus 3x square over x cube plus 1. So now we can replace this y by this expression. So dy over dx is now equal to x cube times the square root of x plus 4 divided by x cube plus 1 times 3 over x plus 1 over 2 times x plus 4, and then we have minus 3x square over x cube plus 1, right? So this is the derivative of y with respect to x. Now we have to find the derivative, that is dy over dx at x is equal to 1. So what we will do, will take x is equal to 1 in this expression. So here we have 1 cube is 1, then we have square root of x plus 4. So 1 plus 4 is 5, and 1 cube is 1, 1 plus 1 is 2, and then we have 3 over 1, then we have half, 1 plus 4 is 5, then we have 3 times 1 square is 1, 1 cube is 1, 1 plus 1 is 2, right? So let us simplify it. We have square root of 5 over 2, this is 3 plus 1 over 10, this is 3 over 2, right? So dy over dx at x is equal to 1 is now equal to this expression. So now let us simplify this expression. So we have dy over dx at x is equal to 1 as square root of 5 over 2. Here we have the LCM 10, then we have here 30 plus 1 minus, that is minus 15, right? So this is root 5 over 2. This is 31 minus 15, that is 16 over 10. So this is 2 8s are 16, 2 5s are 10, 2 4s are 8. So this is 4 root 5 over 5, right? And if we rationalize it, then we can get 4 over square root of 5, right? So the derivative of y with respect to x at x is equal to 1 is equal to 4 times square root of 5 over 5 or 4 over square root of 5.